Hello, Math 95 students. Looking at section 13.2. We're going to be simplifying radical expressions by adding, subtracting, and multiplying these radicals. All right, to combine is combining like terms with these radicals, and to be a like term when a radical is involved, you have to have the exact same radicand. So in other words, the variable has to be the same, or whatever's under that radical has to be identical. And not only that, but also the indexes of these radicals have to be alike as well. All right, so let's look at these examples, and that'll hopefully give us a good idea. Okay, here we have the exact same thing under the radical, and we have the same radical index. So we can combine them. They're like terms. It's like 3 thingamajiggers plus 6 thingamajiggers is 9 of those thingamajiggers. Like 3 pencils plus 6 pencils is 9 pencils. So 3 square root x plus 6 square root x equals 9 square root x. All right. Likewise on number 2, we have the exact same thing under the radical, and we have the exact same radical index. So they are like terms, and we can combine them. 8 thingamabobbers, take away 5 thingamabobbers, is 3 of those thingamabobbers. If I could just write it more neatly. 3 of those, that still isn't very neat. I'm just not satisfied with that. 3 of those 4th roots of x. All right. Number 3. Again, we have identical radicands, identical things under the radical, 3xy squared and 3xy squared, and we have the exact same radical index. So they are alike. So 4 of those things minus 2 of those things is 2 of those things. 2 5th root of 3xy squared. All right. Now let's look at number 4. On number 4, we have the same thing under the radical, but we don't have the same thing for the index. So they are not like terms. Therefore, we can't combine them. So we just leave it just like it is. That's it. That's the answer. You can't simplify it anymore. All right, look at number 5. We have the same index, but we do not have the same radicand. Those are not the same thing, so we can't combine them, and they're not like terms, so we just have to leave it as it is, and that's all we can do. All right, so what about on this one? Well, what are our like terms? We have a 4th root of x term here, and we have a 4th root of x term here, and they're going to combine together. Then we have just a square root of x term here, and a square root of x term here, and they're going to combine together. So the 3 4th root of x plus the 2 4th root of x gives me 5 4th root of x. And the 4 square root of x plus the 7 square root of x gives me plus 11 square root of x. And that's my answer. All right, on number 2, I am going to distribute the 3 first, because that's the distributive property going on. So that's going to be 15 cube root of x plus 1 when I distribute the 3 to that term. And it's going to be minus 6 when I distribute the 3 to that term. And then minus 4 cube root of x plus 1. Then we have this term and this term as like terms. So 15 of those things minus 4 of those things, that would be 11 of those things. So 11 cube root of x plus 1 minus 6, and the 6 does not have any like terms, so it just stays like it is, and that is my final answer to that problem. Next set of problems. All right, look at number 1. The square root of 8 plus 5 square root 2, and you think to yourself, those aren't like terms. The radicals aren't the same because it doesn't have the same thing under the radical. And you'd be right, except that maybe the problem is that there's an added layer to this problem in that if you were to simplify the radicals, they may turn into the same radical. So that's what the added layer of complexity is to this problem. So we are going to simplify the square root of 8 is 4 times 2 and 2 times 2. We have a pair of 2's and an extra 2 left over. Since the index here is understood to be 2, I'm just looking for 2 of a kind. So that means I have a 2 on the outside and an extra 2 left on the inside of that radical, plus 5 square root 2. And now they are alike, right? The square root of 2 and the square root of 2, they're alike. So 2 of those things plus 5 of those things equals 7 of those things. 7 square root 2 is my answer. Try that same kind of approach on number 2. We're going to simplify these radicals. The 45 breaks down to 9 times 5. The 9 breaks down to 3 times 3. So I've got a pair of 3's with an extra 5 left over. So that's going to be 3 square root 5w. Okay. The 20 breaks down to 5 times 4. The 4 breaks down to 2 times 2. I've got a pair of 2's with a 5 left over. So it's going to be plus 2 times the square root of 5w. Now they're alike. 3 things plus 2 things is 5 of those things. 5 square root of 5w is the answer. All right, number 3. Can we break this down? The 3, I can't break that down, but the a cubed, I can break that down because I can break it down to a squared and a. And the understood index of 2 is going to go under that 2, and that's going to come out, and that's going to stay in. So that gives me 5a, because the a came out right there, and 2 over 2 reduces to 1, so it's just a to the first. So it's 5ab on the outside, square root of 3a on the inside because of that extra a left over, and that 3 still in there. Minus 12 breaks down to 3 times 4. 4 breaks down to 2 times 2. I have a pair of 2's and an extra 3. So a 2 comes out. There's an a already out there. And the b squared can just be b squared because 2 already goes into 2. And I just put the 2 under there and that comes out. How does it come out? It comes out as a b. B to the first. So 2ab. And then what's left under that radical is that 3 from there and that extra a right there. So now they are alike. So 5ab square root 3a minus 2ab square root 3a. 5 things minus 2 things is 3 things. So this is just equal to 3ab square root 3a. And that's my answer to that one. All right, similar approach to this example. Break these things down. 16 breaks down to 8 times 2, and 8 breaks down to 2 times 4, and 4 breaks down to 2 times 2. And how many things am I looking for for this index of 3? I'm looking for 3 things, 3 of the same things. So I've got 3 2's together there and an extra 2 left over. And also that x to the 4th can break down to x cubed and x. And the reason I did that is because 3 doesn't go into 4, but 3 will go into 3. So I broke it down to x cubed times x to the first. So I can put that 3 under there, and that'll come out, and this will stay underneath. So what have I got? Well, I've already got a 2 on the outside right here, and then I've got an extra 2 coming out there, so that's going to be 4 on the outside. And then I've got an x to the 3 over 3, so that comes out as an x to the first. And underneath the cube root now I've got a 2 from that 2 right there, and I've got an x from that x right there, so 2x. break down this one. 54 breaks down to 9 times 6. 9 breaks down to 3 times 3. 6 breaks down to 3 times 2. I'm looking for 3 of a kind. I have 3 3s with an extra 2 left over. The x, I can't do anything with that x right there. It's going to have to stay as it is. So what is that going to give me? Minus, I've got a 4 out here, and I've got a 3 that's coming out there with it. So in the 4 and the 3 makes 12. I've got an x already out there, and I've got a cube root. What's under the root? I've got that 2, and I've got that x, so 2x. Are they now like terms? Yes, they are. 4x cube root 2x minus 12x cube root 2x. 4 things minus 12 things makes negative 8x cube root 2x. All right, the next part of this same section is not about adding and subtracting these radicals, but about multiplying radicals. Okay, so we can multiply radicals even when they're not like radicals. Just like we can multiply x squared times x cubed, even though they're not like terms, you can still multiply them and get x to the 5th. Same thing with the radicals. They don't have to be like radicals to multiply. So I just multiply this together, and I have the 5 that's still there, but the square root of 3 times the square root of 6 gives me the square root of 18. Whatever's under that radical, if they're the same index, they can come together and multiply together. And the 18 can break down to 9 times 2, 3 times 3. I got a pair of 3s and an extra 2 left over, so the 3 comes out. The 5 that's already out there, it combines with that to make 15 on the outside. And the square root of 2. 2 left on the inside of the radical. Okay. Here, I can go ahead and multiply the 6x with the 2x, and I can multiply the 2 with the 5. So the 2 and the 5 on the outside of the radicals, they can multiply together and get 10. And the 6x and the 2x on the inside of the radical can multiply to get 12x squared. Then break down the 12, and that's going to be 3 times 4 and 2 times 2. So I got a pair of 2s with an extra 3 left over. And with the x squared, the invisible index of 2 will already go into that, so I can just go ahead and write that as a 2 under there, and that can come out. So what is this going to become? I've got a 10 out here. I've got an extra 2 coming out there, so that's going to be 20 out there. Write that a little darker. So I've got 20 out there. And then I've got this right here coming out as an x to the first out there. And on the inside of that radical, all I've got left is that 3. So that's my final answer for that one. More multiplying radicals. All I'm doing here is the distributive property, where I'm distributing the square root of 5 here. That just, the 3 is not under the radical, so it can't multiply with the 5. It just has to stay outside there. So 3 square root 5. But here, I'm distributing the 5 to the square root 2, and both the 5 and the 2 are under the radical, so they can come together and make square root 10. So 3 square root 5 minus square root 10 is my answer there. I could try to break down the 10 to 2 times 5, but I don't have anything that is a pair of the same kind, so that won't help. I can't break that down. Okay, distribute this to here, and the 3 and the 4 multiply together to get 12. And inside the radical, I've got 5x times x, so that's 5x squared. And then take that and distribute it here as well. The 3, it's going to be minus. The 3 is just going to be still a 3 on the outside. And on the inside, I've got 5x and a 5. So on the inside of the square root, I've got 25x. All right, let's break this down as much as possible. The 5 won't break down to anything that will come out, but the x squared, I can go ahead and put a 2 under there, and so that's going to come out as an x. So that's going to be 12x square root 5 minus, all right, here this 25 breaks down to 5 times 5, right? So that comes out as a 5. That x, I can't do anything with that. It has to stay there. So that's going to be on the outside there. The 5 comes out with the 3, so it's 15 square root of x. These are not like radicals, so I can't combine them. So that's just my final answer right there. All right, here we have more distributing going on. And this time it's the FOIL method, or what I like to call it, the double distributive property. So I'm distributing the 5. So 5 times 4, that's 20. And then 5 times the square root of 3 is just plus 5 square root 3. I can't combine the 5 and the 3 because the 5 is not under the radical and the 3 is. So I just got to write it as 5 square root 3. Then I'm distributing the negative square root 3 to here and to here. So negative root 3 times 4 is just negative 4 root 3. Because again, the 4 is not under the radical and the 3 is, so they can't combine. And then negative root 3 times root 3 is negative root 3 times 3 makes 9. All right, and then the 9 will break down, right, to 3 times 3. So the square root of 9, you know that's just 3 anyway. So pair of 3's, it comes out. So that's going to be, let me rewrite it as 20 plus 5 root 3 minus 4 root 3 minus 3, because that square root of 9 simplifies to 3. Now, combine like terms. The 20 and the minus 3 can combine to make 17. And the 5 root 3 and the minus 4 root 3 can combine to make to make 1 root 3. So plus 1 root 3, or just plus root 3. And that's the answer to that. Do the same thing here. Distribute the 2 root x to both of those. So that's going to be 2 root x times 3 root x is 6 root x squared. Right? 2 times 3 is 6, and x times x is x squared, so the square root of x squared. 2 root x times 4 is plus 8 root x. And then distribute the negative 7 to here. So negative 7 times 3 root x is minus 21 root x. And negative 7 times 4 is negative 28. Now let's see what we can break down. The x squared, right? That's an invisible. 2 is the index, so that can simplify. Just write that index. That invisible 2 is going to come under this 2. And so this will come out. And so it becomes just an x. So it just becomes 6x. And there's nothing left under the radical, so it's just 6x. Plus, the 8 root x minus 21 root x are like terms that can combine. And so that makes, when I combine those, it makes minus 13 root x. And then minus 28. And there's nothing else that is alike, so I can't combine anything else, and that's my final answer there. All right, let's do some more distributing. This time, this is 2 root 3x plus 5 and 2 root 3x minus 5. These are called conjugates. You can have radical expression that are called conjugates when you have like a plus b and a minus b. Those are called conjugates. So the only thing that has changed between these two things is the sign of the second term. So this is like a plus b and a minus b. So anytime you multiply these radical conjugates, let's see what happens. So distribute there, and that gives you 4 square root 9x squared. Right, 2 times 2 is 4, 3x times 3x is 9x squared. Then distribute here. It's going to be minus 10 root 3x. And then distribute here. It's going to be plus 10 root 3x. Then distribute here, minus 25. So, let's see what happens. The 9 will break down to 3 times 3, and so that's just going to come out. The x squared will already reduce. I just put that invisible index 2 under that, and so that will come out. And so what will that be? Everything comes out. The 4 is there, the 3 comes out, and that makes 12, and then the x comes out as an x, and there's nothing left under the radical. All right, so here I've got negative 10 root 3x plus 10 root 3x. Those will cancel out and make 0. So those are gone. And then minus 25 just comes down. And so I guess what I want to tell you here is anytime you multiply a radical expression with its conjugate, let me spell that for you, conjugate. Anytime you multiply a radical expression with its conjugate, the result will not have any radicals in it, which is going to be a very helpful piece of knowledge for the next section. All right, this time we're just multiplying a radical with itself. X minus root 3 squared. So that's going to be x minus root 3 times x minus root 3. So x minus root 3 times itself. And we have to distribute. X times x is x squared. X times negative root 3 is negative x root 3. Then negative root 3 times x is again negative x root 3. And negative 3 times negative root 3 is positive root 9. All right, so what happens? The 9 breaks down to 3 times 3, right? The square root of 9 is just 3. So it's just x squared. And then these are like terms. So negative x root 3 minus x root 3 is minus 2 x root 3. Plus 3. Because the square root of 9 is just 3. And nothing else is alike. So this is the final answer to that. More multiplying radicals. The fun in this section just never stops, does it? All right, so multiplying here. So the 2 and the 7 multiply to get 14. And then inside of that fifth root radical, I've got x squared times x to the fourth, which makes x to the sixth. Then the x to the sixth I can break, because I've got a fifth root, the 5 is the index there. I break that x to the sixth down to x to the fifth times x. And then that 5 index there comes under the 5 there, so that'll come out. And that has to stay underneath. So this is going to give me 14. And then that comes out as an x to the first, so it's just x there. And then the fifth root of, I've got an x still left under the radical. And that's the answer there. All right, let's do some distributing here. Fourth root of x cubed times fourth root of x cubed is the fourth root of x to the sixth. And then fourth root of x cubed minus 6 is minus 6 fourth root of x cubed. And then 5 times fourth root of x cubed is plus 5 fourth root of x cubed. And then 5 times negative 6 is minus 30. So let's see what we got now. This will break down. I'm going to break that down to x to the fourth and x squared. And the 4 will come under that 4 and make that come out. This will stay underneath. So that's going to be x on the outside and x squared on the inside. And then, are these like terms? I believe they are. So negative 6 fourth root x cubed plus 5 fourth root x cubed makes negative 1 fourth root of x cubed. And then minus 30. And nothing else is alike. So this is my final answer. Although let me say, this is good enough for my class, that when what you're doing. Although let me say that I know that you can, my class don't pay attention to this because it may confuse you more, but that you can put the 4 under there and that reduces to 1/2. So this could be written as x and then square root of x instead of fourth root of x squared, because that's the same thing. But don't worry about that for now if you are in my class watching that video. Just wanted to make sure mathematically we know that that is possible out there in YouTube land. We're just not teaching that concept in this class. And that is good enough for this section finally. So good luck on that assignment, and I will see you again in 13.3.